Alright, welcome. In this video, we're going to be working the Algebra 2 Unit 1 review. And this first page, highly recommended, okay? There's a few problems on here that are really similar to problems on the free response section here, upcoming test. And so, of all of these things that we're about to do, part 1 is the one I'm going to emphasize the most, okay? The other ones, they're good for practice if you need the extra practice, but this is essential. Okay, so first question, is BCD a right triangle? Justify my answer. Okay. I know I'm going to need more space than that. So I think I'm going to just, BCD, that one. So I'm going to just kind of copy it here. Oh, pen. All right, so that's going to be D. Here's going to be C down here. Okay, don't like that pen. All right, C will be here, and B over here. And I don't know, I didn't do the best job of drawing it, but over here it looks like this angle right here is the one that looks like it could potentially be a right angle. This is pretty clearly an acute angle, same thing there. So I think I'm going to just check to see, look at the slope of this line, look at the slope of that line, see if they're perpendicular, right? Okay, so the slope of line CB, that's going to be, I'm going to look over here and I'm going to look at rise over run. And I don't know about your copy, my copy didn't print that great. But I can tell it's going to rise by 1, go from y equals 1 to y equals 2, when it goes over by 4. Okay, so I'm going to say that that has a slope of 1 over 4. Okay, rise was 1, run was 4. Okay, the slope of line DC, I'm going to do the same thing over here. It looks like I'm going down 1, 2, 3, 4 when I go over 1. Okay. So I'm going to say that's negative 4 over 1. Okay, and I see that since they're opposite reciprocals, I've got a perpendicular, I've got two perpendicular lines here. And so I know they meet at a right angle, and I know that, yes, it's a right triangle. So, yes. Because line CV is perpendicular to line DC. Yeah, you can see that. Okay, that's number 1. Number 2, is triangle ABD a right triangle? Justify my answer. Okay, we're going to do the same thing. ABD, this one out here. And then B was kind of down into the right a little bit. Okay. All right, is this a right triangle? Justify my answer. So I'm going to be checking the slope of this one, check the slope of that one, seeing if they're perpendicular. If they're not, I'll say it's not a right triangle. And that's kind of what I'm expecting to happen because this one was. Probably wouldn't ask the same question twice. So I'm going to look over here and I'm going to say, all right, the slope of line DA, that's going to be, I'm just going to zoom in and count. Okay, so it went up by 2 when it went over by 1, 2, 3, 4. Okay, so up 2 over 4 is going to be a slope of 2/4. Okay, and then the slope of AB. Okay, I'm going to look back over here. Looks like it's going down 1, 2, 3, 4, 5 when it goes over 1. So I'm going to say that slope is -5 over 1. And I'll show that these aren't perpendicular lines by multiplying their slopes and saying, hey, that didn't come back -1. Okay, and that's not equal to -1, so they're not perpendicular, so it's not a right triangle. Okay. All right, number 3, write the slope-intercept equation for the line that is parallel to line CB. Okay, I think we've already computed the slope of that and passes through the point 1, 3. All right, yeah. So I know, yeah, right here, line CB has slope 1/4. We already did that work in number 1. Okay? So I know I'm going to go over here. I'm going to say, I know the slope-intercept equation is going to be y equals m times x plus b. And I know that I can plug in x equals 1 and y equals 3, and for x and y here, with knowing that m is equal to 1/4, and I can solve for b. Okay? So I'm going to say y is 3, 1/4 of x, which is 1, plus b. Okay, because we'd already determined the slope was 1/4 by doing rise over run up here. All right, and so I'm going to say 3 equals 1/4 plus b. 3 is going to be 12 over 4. So 12 over 4 equals 1 over 4 plus some number, and that number is going to have to be 11 over 4. And, okay, that is not it. They asked for the slope-intercept equation. So y equals 1/4 x plus 11 divided by 4. Okay, if you wanted to call that 2.75, be my guest, right? Same number. All right. And then we're going to, okay, compute the slope of line AB. Already did it. Okay. Already did that. It's -5 over 1. Okay. But if you wanted to do it, using the officially approved, algebra way that we've learned how this unit, we're going to use the slope formula. And point A, I'm going to need to label these coordinates. Okay, that's looking like 2, 7. Point B is 3, 2. C is -1 and 1. And D is going to be -2 and 5. Okay. Now, if we're wanting to compute the slope of line AB, we could do 2 minus 7 divided by 3 minus 2, and we would see that it was -5 over 1. We'd already done that. So, the y-intercept of line AB, okay, that's a more interesting question. That's not something we've already done. And so AB, we've seen that has a slope of -5. We just did that. And so y equals -5x plus b. Right? So all we need now is a point that we know is on line AB that we can plug in for x and y to find that value of b. Okay? And so I'm going to just choose 3 and 2. Looks like smaller numbers. So x is 3, y is 2. So 2 equals -5 times x, which is 3, plus whatever the y-intercept is going to be that we're going to solve for. And 2 is going to equal -15 plus b. And I can solve for b by adding 15 to both sides of this equation. And so 2 plus 15 is going to be 17, and that's going to be equal to b. Right. Now we're going to, wait, yeah. So you could say 17 equals b. That would be a perfectly fine response. The y-intercept, probably the best response would be the coordinates 0 and 17. And, we go back and we look at our picture, and that actually makes some sense, right? It's pretty steep. It's going up this way. Right, it would make sense that our y-intercept is positive and pretty big, right? So now we're going to write an equation for line BD. So we're just going to need a point and a slope. So, yeah, we've got, do we have a slope for BD? No, we do not. Okay, that was kind of, I guess it was the hypotenuse of both triangles. So we're going to go over here, and we're going to need to find a slope for line BD. Okay. So the slope is going to be equal to, it's going to be y2 minus y1, 2 minus 5 over x2 minus x1, 3 minus -2. Okay, and 2 minus 5, that'll be -3. 3 minus -2, that's +5. Okay. And then we've got a point. It doesn't really matter which one we choose. Maybe I'll choose point D, -2 and 5. And then I'm going to go in there and I'm going to write an equation. Me personally, I'm going to use point slope form. Okay? If you can't remember that one, then you're going to have to write y equals mx plus b with plugging in on this for m and then plugging on this with x and y to then solve for b. Okay, which is going to take more steps than just remembering the form of point slope. So y minus the y coordinate of the point I know is on the line is equal to the slope times x minus the x coordinate of the point that I know is on the line. Okay? And it said an equation, so this will do. Right? All right, now let's find the x-intercept of line BD. Okay, well, I've got an equation for it, and I'm going to say the x-intercept, that's where y is equal to 0. And so I'll say 0 minus 5 is equal to negative 3/5 of x plus 2. And I can solve for that. Okay, 0 minus 5, that's going to be negative 5. I'm going to have to deal with this thing that's on the outside. You know, I don't really want to distribute a negative 3/5 to x and 2. So what I could do is I could multiply both sides of this equation by 5 to begin with to get rid of the denominator, right? And I can already tell I'm going to need more paper. Probably should have given y'all more room to work as well. All right, so I'm going to multiply both sides of this equation by 5, and I'm going to have negative 5 times 5, and that's going to be negative 25. And that will be negative 3 times x plus 2. Okay, maybe now I'll distribute, because that's not so bad, right? Kind of trying to get out of the fraction world, because I know that that's where a lot of errors occur, at least for me. Okay, so I'm going to say, all right, negative 25 equals negative 3x minus 6. Okay, good there. Now we're going to start solving at x by adding 6 to both sides. So negative 25 plus 6 is going to be negative 19. And that'll be equal to negative 3x. And if I want to solve for x, I'm going to have to divide both sides of this equation by negative 3. And so I'll say, all right, x is going to be negative 19 over negative 3, which is the same as 19/3. Okay, so that's going to be the x-intercept. And if you wanted to say x equals 19/3, I think that would probably be fine. But if you wanted to say that the coordinates of the x-intercept were 19/3 and 0, that would be a really good answer too. Okay. All right. Now number 8. You know, you're still watching. This is one that I would really, really emphasize. You know, like this is one that's different from what you've seen on the quizzes and the homework and the notes. Yeah, you might be asked a similar question real soon on the test. Okay. So an altitude of a triangle is a line segment that passes through a vertex and intersects the opposite side at a right angle. And we're going to write an equation for an altitude of triangle ABD. That sounds like something's going to need more paper as well. Okay. So I'm going to draw ABD. Okay, this is the one that we determined was not a right triangle. So I don't have to worry about one of the altitudes just being one of the sides. Okay. I'm going to actually come in here and label the things that we've already computed. Okay, I have A, B, D, and okay, over here earlier we computed this slope equals 2/4, that's a half, and the slope of AB is negative 5, and then hold on, we found that other slope as well for line BD. Yeah, that was negative 3/5. Yeah, you can still see that. Okay, so I'm going to start working with that. Okay, and there's going to be 3 different correct answers, right? Because there's 3 different altitudes. One right here, one right there, and one over here. And maybe I'll use some color to differentiate between those. So for this one, which I think is the easiest to see, I'll do the one that goes through point A and sits perpendicular to side DB. Okay. So this one is going to have a point. So it's going to have point A, which has coordinates 2 and 7. It's going to have slope perpendicular to line DB, so that's going to be positive 5/3. Okay. And then I'm going to write the equation. Okay. Using point slope form, y minus the y coordinate of the point is equal to the slope times x minus the x coordinate. Okay. And again, I just want to emphasize that you can do y equals mx plus b, plug in m equals 5/3, plug in x equals 2, plug in y equals 7, and solve for b, and get an equation that way. And that works just as well, but that takes longer, and I feel like is more error prone, so I'm going to use pencil form. Okay, I need a blue pen. Not sure what happened to mine. Okay, the second one is going to be over here, and this one might be tough for me to draw. Actually, no, it looks like it's kind of perpendicular. Okay, this one is going to go through point D, and that's going to be -2 and 5. Okay, the slope needs to be perpendicular to this one that has slope -5, so that would be positive 1/5. And then I can write the equation, y minus 5 equals the slope times x minus -2. Okay. And then for the third one, let's see, I'm not seeing any green pens. Right, so this third one is going to be, I'm going to have to go this way, and maybe it looks like that. Okay. Yeah. So this one's going to go through point B. So its point is 3 and 2. Okay, the slope needs to be perpendicular to 1/2, so that would be -2/1. And then the equation is going to be y minus the y coordinate equals the slope times x minus the x coordinate. Okay. And really just want to emphasize that any one of these three equations is going to be good enough, right? You don't have to give all three. It just said an equation for an altitude. One equation, one altitude. Okay, but I was just showing you that there's three different right answers. In case you'd already tried this yourself and you're trying to see if you were right, I wouldn't want you to only do the one in red, and you have done the one in blue perfectly fine and think you were wrong. Okay. All right. Who knows? I might need green later. All right. So that's the end of the first page. All right. Now let's do review part 2. But before I begin, I do want to remind you that in my opinion, the best way to review for this test is not necessarily just grinding through every problem on this review and saying, okay, I'm good. But it's going to be going back and working the quizzes, working the problems you didn't get right on the quizzes, making sure you're good on those, making sure you're good on the ones you did get right, because some of those were a couple weeks ago. Really look to the quizzes for guidance on what you need to practice on, and then come back here and practice, right? Okay, but now I'm just going to work on the problems. So the function below shows the cost of a hamburger with different numbers of toppings, t. Okay, so f is going to be the cost, and t is going to be the number of toppings. Okay, so the function is 190 plus 1.40 times t. What is the y-intercept, and what does it mean? Okay, well, that's just going to be where t equals 0. Right, same idea. If we have t instead of x, it's just whatever the input variable is, it's 0. That's going to be the y-intercept. Okay, t equals 0. F of 0 equals 1.90 plus 1.40 times 0. And we know that anything times 0 is equal to 0. And so that's going to be equal to 1.9. Okay, that means that with 0 toppings, the cost of a hamburger is $1.9. Okay, so I would say hamburger with no topping costs $1.90. All right. What is the slope and what does it mean? Okay, and y equals mx plus b. Okay, they did b plus mx, right? Okay, the slope is the number that's multiplied by x. Okay, so in this one, it's going to be the number that's multiplied by t, and it's going to be that 1.4. And you multiply the number of toppings by 1.4, and that's what you add on to the cost of a hamburger with no toppings. So that stands to reason that 1.4 is going to be the cost of each topping. Okay, so I'm going to say the slope equals 1.4. And that means that each topping costs $1.40. If Jody paid $3.30 for a hamburger, how many toppings were on Jody's hamburger? Okay, well, that means the cost equals 3.3. So f of t is the cost. So 3.3 is going to equal 1.9 plus 1.4 times t. And then we're going to solve for t. We're going to start by subtracting 1.9 from both sides. 3.3 minus 1.9, that's going to be, okay, well 3.3 minus 1 would be 2.3. And then if I subtracted 2, that would be 1.3, so it should just be a little bit bigger than subtracting 2. So that's why I'm thinking 2.4. Hold on. I said 1.4, but then I wrote 2.4. I was like, how is that going to divide evenly? And I don't think you can get a half of a topping, right? 1.4 equals 1.4 times t. Yes, okay, there we go. All right, and then we're going to divide both sides by 1.4. And we're going to say t is 1.4 divided by 1.4, and we know anything divided by itself is 1. Or we could probably solve this one with our eyes, right? We can say 1.4 equals 1.4 times some number t, and that number's got to be 1. Okay. All right. Now, okay, here's a completely different set of problems, especially for people in my sections of Pre-P Algebra 2. We didn't do a whole lot of practice on interval notation. It seemed to me like y'all were pretty all right with it, but it never hurts to just make sure, and this is a very comprehensive list of problems that will make sure that you're good with it, right? Okay, so the two examples. We've got the inequality, the corresponding interval notation, and then the graph of the interval on the number line, okay? So then they've got one even that's, you know, kind of unbounded to one side, is what we would call that. And so those are your two examples, okay? But x is less than or equal to 3. I'm going to start with the graph. Okay, my graph probably won't be as nice as theirs, but okay, here's 3. That's just where I've decided it's going to be. And it's going, if x is less than or equal to 3, we're going to include 3. So I'm going to color that in, fill it in. And then I'm going to shade in places where x is less than 3, right? So less than, where I've got the squiggly lines, and then equal at that filled in circle. All right, and if we're going to write this as an interval, this is all of the ones less than 3, so it goes all the way to negative infinity. So we say it starts at negative infinity, okay, and always a parenthesis with infinity or negative infinity, because infinity and negative infinity, they're not real numbers, and so they can't, x can't equal them, right? Because equals is a relationship between two real numbers, okay? And then it goes all the way up to 3, and it's going to include 3, so I use that square bracket, okay? All right, from negative infinity up to 4, I will draw this. Okay, it's going to go all the way up to 4, but then we're not going to include 4, so I'm going to draw an open circle there. And if it goes all the way to negative infinity, okay, then I'm just going to color in here. Okay, and maybe give this arrow a little bit more emphasis. Okay. This looks like the set of all points where x is less than 4, not equal to 4, right? So just less than 4. X less than 4. All right. Okay. This is the set of all numbers between 2 and 6, including 2 and including 6. So if we want to write it as an interval, we're going to start writing 2, 6. If we're including 2, we're going to use a square bracket. If we're including 6, we're also going to use a square bracket, right? And then we can do the same thing with x, right? If we know we're going to write it as an inequality, we know we're going to say x is between 2 and 6. Okay, and if it can equal 2, it'll be less than or equal to, and if it can equal 6, it'll be less than or equal to. Like that. Okay, and then, okay, from positive 5 up to infinity, we can draw a picture of that. There's 5. Okay, that's going to be far enough. From 5 up to positive infinity, so okay, we're going to go that direction. I might give the rest of the number line just ideas there. Okay, but this is going to be the set of all points where x is greater than 5 or equal to 5. So x is greater than or equal to 5. Okay. Here we have what looks to me like x is less than or equal to 1. Okay. And then that is not where that was supposed to go. Pardon me. All right. X less than or equal to 1. Okay. And then to write that as an interval, okay, it goes all the way over here towards negative infinity. So it's going to start at negative infinity, and then it's going to end at 1. We're going to include 1, but we're not going to include negative infinity because, again, we never include infinity or negative infinity. Okay? Never a square bracket around infinity or negative infinity. Okay, x is less than 1 or x is greater than or equal to 5. Oh, or that's not something we've talked about in my classes. We won't really need to run into this situation for a couple of units, but pretty soon we're going to solve some equations that involve the absolute value of x, and then we'll need some of these or statements. Okay, when we say or, okay, oh, whoops, x is less than 1. So I'll draw an open circle there. Okay, and I'll draw all of these points, right? Okay. Or x is greater than or equal to 5. Okay, maybe 5 is here. And this is going to be the set of all points that's greater than or equal to 5 out here. Okay. When we say or, we're willing to include both of these intervals. Okay. And how we would write this in interval notation, you probably don't know this yet if you're in my class, but it goes from negative infinity up to 1. And the symbol for or is going to be like this U-looking thing. Kind of a big one though, and it doesn't have the tail on it like a regular U would. Negative infinity to 1 union 5 to positive infinity. All right, and then over here, okay, we've got negative 5 up to negative 1. Okay, we're not including negative 5, so we put a parenthesis. We're not including negative 1, so we put a parenthesis on that. Okay, to write it as an inequality, okay, where it's a bounded interval, so we're just going to say negative 5 up to negative 1. Okay, but it's going to be strictly less than because we've got 2 parentheses or 2 open circles. How do you want to look at it? All right. And then x is any real number. Okay, well, okay, I don't want to waste a bunch of ink on this, but this is just the whole number line. And I guess in interval notation, we would say that was negative infinity to infinity. Can also, right, okay, that's the real number line. That's the symbol for that. Okay, that was great. Okay, this was, I don't know, maybe some practice we needed if you're in my class. But maybe you've already done that part, and hopefully you skipped through that. All right, now we're going to find the slope and y-intercept of the graph of each equation. Then we're going to equation in slope-intercept form. All right, with each of these, I'm going to solve for y, and if you already know this formula for slope off of ax plus by equals c, good for you, just use that. Right? But you can check your answer against my work. Okay, for number 9, I'm going to start with 0.2x plus 0.5y equals 1.6. Okay. If you want to solve for the y-intercept, it's really set up for it. I might do that. Y-intercept 0.5 times y equals 1.6. And I just put down the y because the y-intercept is the place where x equals 0. And if I plug in x equals 0, 0.2 times 0, that's going to be 0, and 0 plus half of y, well, that's just going to be half of y. And then I'm going to divide both sides by 0.5. Okay, but we know that 0.5 is a half. And we know that dividing by a half, we would flip and multiply. Okay, so it would be like multiplying by 2. So y is going to be equal to 1.6 times 2. Another way you could look at it is, okay, what number would I multiply both sides of this equation by to get 1y? 2 times 0.5 is going to be 1. So 1y is going to be 1.6 times 2. That's going to be 3.2. Okay. And then I'm going to solve for y. So 0.5y equals negative 0.2x. I need to subtract 0.2x from both sides of this equation to get at y. And then I still have plus 1.6. Okay. Then I'm going to divide this whole equation by half, which is like multiplying by 2, like I just said. So I'm going to multiply both sides by 2, divide by half, same thing. And I'm going to double everything. 1y equals negative 0.4x plus 3.2. I guess it's good that I got 3.2 both places, right? And then, okay, the slope will be equal to negative 0.4. All right. Number 10. 3x plus 7y equals 10. All right, and then I'm going to start with y-intercept. Okay, that's where x equals 0, so 3 times 0, it's 0 plus 7y equals 10. I'm going to solve for y in this equation by dividing both sides by 7. And y will equal 10 divided by 7. Okay, I don't know what that is decimal-wise. I don't care either. It doesn't really matter, right? We're just going to write it as 10 over 7. And then we're going to say, all right, 3x plus 7y equals 10, and we're going to solve for y. We're going to start by subtracting 3x. And then we're going to divide both sides of this equation by 7. We just have to remember to divide everything by 7. So 1y equals negative 3 divided by 7 times x, plus 10 divided by 7. Okay, we're seeing that 10 over 7 number again. That's good. Now we know the slope is negative 3/7. All right. Okay. Now number 11, I'll just copy that problem down here. 6x minus y equals 9. Okay, this one looks like it is just really set up for me to solve for y, right? I could just maybe add y to both sides of the equation, subtract 9. It looks like it's just about to happen. Like, it's already part of the way solved for me. Because it doesn't have any number attached to it. So I'm going to try to get rid of the negative by just adding y to both sides of this equation. So I will have 6x equals y plus 9. But then I want to solve for y on its own side of the equation, so I'm going to subtract 9 from both sides. And I'll get 6x minus 9 equals y. Okay. And now I've got the slope and the y-intercept just right there waiting for me. Okay, the slope is going to equal 6. And the y-intercept is going to be equal to negative 9. And then number 12 is 14x minus 21y equals 7. Okay, like this one. Okay, all right, let's start with the y-intercept, right? So the y-intercept, that's going to be where x is equal to 0. Okay, so 14 times 0 minus 21y is equal to 7. Right? And then I'm going to divide both sides by negative 21 to solve for y, and I'm going to get 7 over negative 21. But I know 7 divides 21, so I can simplify it. Not that I necessarily have to, but you know, probably if this was a multiple choice question, the answer wouldn't be 7 over negative 21, right? It would probably be negative 1/3. And so we need to be able to simplify fractions, right? And so this is 21, or 21 is 3 times 7, so I could cancel the 7s. I'd be left with a 1 over negative 3, which is the same as negative 1/3. If I wanted to solve for the slope, I would start over here. I would go over here, 14x minus 21y equals 7. I'm going to start to solve for y. Okay, maybe I'll add 21y to both sides. Okay, I usually would subtract 14x, but it doesn't really matter. Okay, I'm going to try to solve for y now, so I'm going to subtract 7. Okay, so 14x, I can't really do anything with 14x and 7. Those aren't the same type of term. So I'll just say 14x minus 7, and that's 21y. And then I'll solve for y by dividing both sides of this equation by 21. And now I just have to remember to divide everything by 21. Okay, so 14x divided by 21 minus 7 over 21 equals just 1y. And, okay, 14x divided by 21, okay, I wrote that differently from how I would usually write it, but if you think about it, you know, multiplying by x and then dividing by 21 is going to be the same as dividing by 21 and then multiplying by x. I'll let you think about that if you needed to. But, all right, these fractions can be simplified. 14 over 21, well, 14 is 7 times 2, and this is 7 times 3, so it's going to be 2/3. Okay, so 2/3 x minus 1/3 equals y. It looks like I've already found the y-intercept, and it was negative 3rd, so that's good. So the slope is 2/3. I'll just report that. Move on. Right. We're doing okay. All right. The next set of questions is just find the x-intercepts and y-intercepts of the graph of each equation. Might have been good that I did that first, but you know. All already made the copies, right? So I'm going to say, all right, number 1, 5x plus 4y equals 20. Okay, so this one, okay, if I want to find the x-intercept, okay, I just happen to know that this one's going to kind of look like that. The x-intercept is going to be this point right here, the point where y on the y-axis is going to be equal to 0. So I'm going to say x-intercept is where y equals 0. And I'm going to say 5 times x plus 4 times 0 equals 20. So that's 5x plus 0 equals 20. 5x equaling 20. And then I can solve for x by dividing both sides of this equation by 5. So x is going to be 20 divided by 5, which is 4. Okay. If I wanted to find the y-intercept, I could do that. Scoot that over a little bit. The y-intercept, we've talked about this in class. This is the point where x is equal to 0. Okay, so I'm going to plug in x equals 0, and I'm going to solve for y. Okay, so 5 times 0 plus 4y equals 20. And so that's 0 plus 4y equals 20. Okay, divide both sides by 4. 20 divided by 4, that's going to be 5. So that's y equals 5. And so I will label these. Not drawing the scale, but still a pretty good sketch. All right, number 2. 2x minus 5y equals negative 7. Okay. For the x-intercept, I'm going to plug in y equals 0. And I'm going to say, all right, that's where negative 5y equals negative 7, right? Because 2 times 0, that's going to keep happening. I'm just going to plug in y equals 0, or, oh, yeah, pardon me. I'm solving for the y-intercept right now. Went a little too fast. But I am going to speed this up a little bit. So y equals 0, so it'll be 2x minus 0 equals negative 7. Okay, 2x equals negative 7. Divide both sides by 2, and I get negative 7 divided by 2. Okay, that's a perfectly fine number. If you want to call it negative 3.5, be my guest. Okay, for the y-intercept, okay, we're going to say that's where x equals 0. Then I'm going to plug in 2 times 0 minus 5y equals negative 7. And I can divide both sides by negative 5, and I'll get y is negative 7 over negative 5, which is the same as 7/5. All right. Sure if I'm going to be able to fit all 4 problems on this page, but it's all right, I got plenty of paper. 3, 4x minus 8y equals 10. Okay. For the x-intercept, I'm going to say, all right, that's where y equals 0. I get 4x minus 8 times 0 is going to equal 10. So 4x equals 10. I'm going to solve for x by dividing both sides by 4. And I can say that's 10/4. Okay, but that's not fully simplified. These are both even numbers, so I can divide them both in half, and I would get 5 divided by 2. And then to find the y-intercept, it's going to be where x is equal to 0. Okay, so 4 times 0 minus 8y equals 10. And that's negative 8y equals 10, and I can solve for y by dividing both sides by negative 8. Okay, but these are both even numbers again, so I will be able to simplify this. And that would be 5 over negative 4, which is the same as negative 5/4. Okay, but there's another one. Number 4 is 9x plus y equals negative 1. Okay. If I want to find the x-intercept, I'm going to plug in y equals 0, and I will have 9x equals negative 1. Okay. And I'm going to solve for x by dividing both sides by 9. Okay. This is the type of equation I know that I see on the quizzes in this unit. So where we were dividing both sides by a whole number and the answer was a fraction, I know that was a place where I saw a lot of errors popping up. So I'm going to say that's negative 1 divided by 9. Okay, check for reasonableness, right? 9 times this number equals negative 1. Yes, okay, that does make sense. 9 times negative 1/9 would equal negative 1. Never hurts to check for reasonableness, right? especially like, I don't know, during a test or something. So the y-intercept, okay, that's going to be where x is equal to 0. And I'm going to have, all right, 9 times 0 plus y equals -1. Oh, look, y equals -1. There it is. Okay, that's all for that one. How many pages? I've got 3 pages left. Okay. All right, probably shouldn't be taking so long, right? Hope not. Okay. Fastest way to just get right to them. So the standard form of an equation that passes through the given point and has the given slope. All right. I think it's time for us to kind of discover the formula for. Oh wait, no. Just forget that. Try again. We've got ax plus by equals c. Okay. The slope, if I solve for y, it's by equals -ax plus c. And then I would divide both sides by b, right? We've done this a few times already, just even in this video. A lot of times throughout the unit. Okay, I got to divide everything by b. And I can see that the slope of this is going to be -a over b. Okay, so what I'm saying basically is what we can do is we can make a the negative of the slope, make b equal to 1, and then figure out what c is. That's my plan, right? Because if I know I'm going for, I'll do it like forwards one way, and then I'll just use the shortcut after that. So if I was going for y equals mx plus b, let's say on number 1. Okay. I know that y equals 1 when m is equal to 4 and x is equal to 2 plus b. Okay, so I can solve for b. I can say 1 equals 8 plus b, and so I would subtract 8 from both sides to say that b equals -7. And then I could say that, all right, I've got y equals 4x minus 7. Okay. If I wanted to solve for a standard form equation like ax plus by equals c, I could subtract 4x from both sides. Okay, so then I would have, it's getting a little bit crowded, but -4x plus y equals -7. Now, I don't know what your definition of standard form is. I think for some people, they really want a to be positive and an integer, and b to also be an integer if possible. And so if we needed that, we would then multiply both sides of this equation by -1 to get rid of that negative. And so I'd have to multiply everything by -1, and I'd have 4x minus y equals +7. And you know, now that I'm thinking about it, what we can do is we can make a equal to the slope, b equal to -1, and then it'll be easy, and we'll just solve for c. Yeah, I think that's going to be the way to go. Who knows? Maybe that was what the author of this textbook intended for students to do. I'm not sure. But, we just stole this out of the textbook. So, number 2. Okay, the slope equals 6. So I'm going to do 6x minus y equals c. Okay, that's going to be, if I was to solve for y by maybe adding it to both sides and then subtracting c, I would get a slope of 6. Okay. And now I'm going to plug in x equals -7 and y equals 2. Oh, interesting. Okay, 6 times -7, well, 6 times 7 is 42, so that would be -42. Minus 2 more equals c. So c is going to be -44. Okay. My equation is going to be 6x minus y equals -44. Okay. Now, I will work number 3. So the point, you can barely see that. Okay. The point here is 1/2 and 3, and the slope is 5. So I'm going to start with, I'm going to do 5x minus y equals c. And then I'm going to use x equals 1/2 and y equals 3. So 5 times 1/2 minus 3 equals c. So 5/2, that's like 2.5. 2.5 minus 3, that's -1/2. So that would be 5x minus y equals -1/2. Okay, and maybe you want, I don't know, maybe your definition of standard form, you want to have everything be integers if that's possible. So I'm going to get rid of that 2 by, I'm not dividing, multiplying both sides of this equation by 2. Okay? So I just got to double everything. 5x times 2, that's going to be 10x. Negative y times 2, negative 2y. Negative 1/2 times 2, that'll be negative 1. Okay? And that's another standard form equation. Number 4. Point is 4 and 9, and the slope is 3/4. Okay, I'm going to actually go start with the same kind of skeleton, the same way I've done the past couple, and then we'll just kind of, like the last one, just multiply by whatever denominator we have at the end to get it into where they're all integers. All right, number 4. AX, so A is going to be the slope, minus 1y equals C. And then 3/4 of x is 4. Oh, it rewarded us for doing this. Okay, so that must have been the intended method. Minus 9 equals c. So 3/4, well, 4 is 4 over 1. Okay, so 3/4 times 4 over 1, that'd be 12 over 4. That's going to be 3. And 3 minus 9 is negative 6. Okay, so now I've got 3/4 x minus y equaling negative 6. Okay, and if I wanted to get rid of that 4 in the denominator, I would multiply both sides of this equation by 4, which means I'm going to have to multiply the x and the y and the negative 6 by 4. So I'll have 3x minus 4y equals negative 6 times 4 is going to be negative 24. Right. Number 5. Negative 6 and 7 with a slope of 0. So 0x minus y equals c. X equals negative 6, y equals 7. Wait, yeah, 0 minus 7 equals c. C equals negative 7. Okay, I guess that's 0x minus y equals negative 7. That's a weird way to write that equation. I think I'll just write it in y equals 7. But, okay, I guess that's standard form. Okay, and then number 6. Wow, that threw me off. 6 is going to, okay, ax 1x plus, no, try that again. Okay. Doing ax plus by equals c, where a is equal to the slope and b is equal to negative 1. All right, so 1x minus y equals c. Okay, I'm using x equals 8 and y equals 3. So 8 minus 3, that's equal to c. C is 5, so this is x minus y equals 5. Okay, yeah, that works. All right, now we're going to write the point-slope form of an equation of the line that passes through each pair of points. Okay, this will be easy. We just need to find some slopes first. So I think I'm going to kind of do these all go, because I've only done the slope formula once or twice in this video so far. So I'm going to do the slope for all 6 of these, and then I'll write all 6 point-slope form equations. Okay, so I'm going to do y2 minus y1 for the slope, right? The slope is rise over run, so it's y2 minus y1. Over x2 minus x1, that's negative 8 minus 6. And that'll be 5 minus 3 is 2. Over negative 8 minus 6 is going to be negative 14. Okay, and I can simplify that. That's going to be negative 1/7. Okay, over here, the slope is going to equal y2 minus y1 over x2 minus x1. Okay, so 7 minus 9 is negative 2 over 10 plus 1 is 11. Okay, can't simplify that. I'm going to leave it as it is. Okay, the slope is going to be y2 minus y1 divided by x2 minus x1. 8, that's going to be negative 9 divided by negative 8, so that's 9/8. There we go. Okay, this next one, y2 minus y1 divided by x2 minus x1. Okay, so negative 6 plus 4 would be negative 2. And 5 plus 3 is going to be 8. Okay, that's negative 2/8. That's the same as negative 1/4. All right, number 11, 2, 9, and 9, 2. All right, so y2 minus y1 over x2 minus x1. Okay, 2 minus 9, that's negative 7, and 9 minus 2, that's positive 7. Okay, so that slope is negative 1. And then the last slope here, it's going to be y2 minus y1 divided by x2 minus x1. Okay, negative 10 minus negative 4, negative 10 plus 4, that's equal to negative 6. Divided by negative 6 plus 1 is negative 5. Okay, that's going to be positive 6/5. Okay, now that I've got a slope ready for all of these, I'm going to pick whichever point I like, use the slope, write an equation. All right, so here we have, all right, I'll use the point 0.63. Slope is going to be negative 1/7. I don't usually put the slope in parentheses, but just did. So my equation is going to be y minus the y coordinate is equal to the slope times x minus the x coordinate. Number 8. Number 8, I'll choose negative 1, 9. The slope is negative 2 over 11. Okay. So my equation will be y minus the y coordinate is equal to the slope times x minus the x coordinate. Number 9, the slope is 9/8. I will choose 8 and 5. I'm just going to keep choosing the first point. Okay, slope 9/8, point 8 and 5. Okay, so my equation is going to be y minus 5 is the slope times x minus 8. Okay, for 10, so you can see that slope is negative 1/4. I'm going to choose negative 3, negative 4 as my point. And then my equation will be y minus negative 4 is equal to the slope times x minus negative 3. Two more. The next slope is going to be negative 1, and I'm going to use the point 0.29. But, yeah, okay, this is one where it doesn't matter which point. You can't mess it up, right? As long as you don't forget to put the minus in, right? Point, I'll do 2.9. Slope here was negative 1. And so my equation is going to be y minus 9 equals negative 1 times x minus 2. Okay, the last one, I'll use negative 1, negative 4 with a slope of 6/5. Negative 1, negative 4. Slope 6 over 5. So my equation will be y minus negative 4 is equal to 6/5 times x minus negative 1. All right, that was a lot. Okay, 2 pages left. That's a nice quick one. All right. Determine the slope of each line. I think this just caught my eye, and I was interested by it. So we're going to go over here. I feel like there's lots of ways that I could take this problem set. I think I've actually already used this figure on one of the homeworks, maybe, but I feel like there's a lot I could do with this. But we're going to determine the slope of each line. Okay, it's a vertical line. I'm just starting us off with a bad situation. Okay, so the rise is 2 when the run is 0. So 2 divided by 0, we can't divide by 0. Okay, that doesn't exist. Okay, so I would say slope for A, that does not exist. D and E. All right, for slope B, Let's find b. It's over here. Okay, I rose -2 when I ran by 2. So that would be -2 over 2, which is -1. For slope c, that's right here. I rose by 2, went from 2 up to 4 when I ran by 1, 2, 3, 4, 5, 6. So it's going to be 2/6 or 1/3. And I'm seeing now that it did go through that grid spot right there. It wasn't as clear as that one right there where it was actually marked. Okay, slope d. Okay, it's right here. Okay, I rose -1, -2, -3, -4 when I ran by 2. So that's -4 over 2, which is -2. Okay, slope e. Okay, that's a horizontal line. It's going to have slope 0. See, I didn't rise. I rose by 0 when I ran by 1, 2, 3, 4. 0 divided by 4. 0 divided by a number is 0. Something divided by 0, that's what's bad, right? So the slope of e is 0. The slope of f is going to be, where's f? F is this one up on top. So it rose by -2, went down by 2, when it ran by 1, 2, 3, 4, 5, 6. So -2 over 6, we know we can simplify that. That's -1/3. With g, here we have it over here. Say I rose by 1, 2, 3, 4, and I ran by 1, 2, 3, and over 3 up 4. So the slope of g is equal to, I already lost it, up 4 over 3. Okay, we can't simplify that. That's good enough. Slope h, right here, is, okay, it rose by 2 when it ran 1, 2, 3, 4, 5, 6, 7, 8. Okay, so up 2 over 8, slope of 2/8. Okay, I can simplify that. That's 1/4. Slope I is going to be, all right, up by 2 when it went over from 1 to 10. So that's over by 9. Up 2 over 9. And the slope is going to be, okay, it went down by 1, and it went from x equals 2 to x equals 10. So it went down 1 when it went over 8. That's right. All right, last page. Determine the value of r so that the line that passes through each pair of points has the given slope. All right, we're going to set up the slope formula. Hold on. Yeah, I think that's going to be the easiest way. Although I'm trying to remember, I saw a new way of solving this type of problem this morning in one of my classes, when we were grading the quizzes. Somebody saw an interesting and different way. Oh, I don't think that would be as useful here. Okay, so I'm just going to set up slope formula for number 7. On one hand, slope is -2/7. That's what they're telling us. But on the other hand, m is equal to, rise over run, y2 minus y1, 4 minus r, divided by x2 minus x1, 3 minus 10. So, okay, you can say that's 4 minus r over -7, and that's equal to -2 over 7. Okay? Now, wait a second, that -7 is a little annoying, right? But maybe, I could, actually I'll cross multiply. I'll be safe here, right? Don't want to assume anything. So I'm going to say -7 times -2, that's 14, is equal to 7 multiplied by 4 minus r, which we need to remember to distribute. Okay. So that's going to give me 14 equals 7 times 4, that's 28, minus 7r. And then I'll start solving at r, so I'll subtract 28, 14 minus 28, that will be -14. Okay, now it makes sense. Negative 7r equals negative 14. What number can I multiply by negative 7 to get negative 14? That's going to be r equals 2. All right. Now, you could have also said that because of the 4 minus r, that negative was, I wanted to say, okay, 4 minus r needs to equal positive 2. And that would be an easier way to solve it, but you'd have to know that, oh, I can multiply both sides of this equation by negative 1. That would kill off this negative, but not affect these. Okay, we haven't really talked about the nature of algebra with fractions in this class yet, and so I just didn't want to make any assumptions that were unfounded, right? So number 8, we've got slope equaling 3/4, but that's also equal to, okay, I'm going to do y2 minus y1, r minus negative 3, divided by x2 minus x1, 7 minus negative 1. Okay, so now that's telling me, I'm going to go up here, 3/4 equals r plus 3 divided by 8. I think I'll cross multiply. Okay, so 8 times 3, that's 24. And that's going to be equal to 4 times r plus 3, right? Cross multiplication, good for solving proportions. Not good for other scenarios, like, I don't know, multiplying two fractions or dividing fractions, not a good idea. Okay? Cross multiplication, strictly for solving proportions, which is what we have, fraction equals fraction. Okay? So, you know, I would frequently, actually, yeah, I'm going to encourage you to distribute, because we need to practice that. It's an algebra class. So 24, that's going to be 4 times r plus 4 times 3. That's 12. Okay? And this, I mean, we could have started by dividing both sides of this equation by 4. That's an option you have. You would get the exact same answer. Okay? Just suggesting that. And if you did that, you're not wrong. Okay? So I'm going to subtract 12 from both sides. 24 minus 12 is 12. That's going to be equal to 4 times r. And I'm going to solve for r by dividing both sides by 3. I mean, pardon me, dividing both sides by 4 and getting 12 divided by 4, which is 3. Okay, but again, this one we could probably solve just by looking at it. All right, now slope is going to be equal to negative 1/2 is what they're telling us. And then it's also going to be equal to 4 minus r divided by 10 minus negative 2. 4 minus r over 10 minus negative 2. All right. So negative 1/2 equals 4 minus r divided by 12. Okay, cross multiply. It's going to be 12 times negative 1 equals 2 times 4 minus r. Okay, and I will distribute. And that's negative 12 equaling 8 minus 2r. And now I can solve for r. Say, all right, I'm going to subtract 8 from both sides. And I'll have negative 12 minus 8 is negative 20. Equaling negative 2 times r. What's a number I can multiply by negative 2 to get negative 20? Ah, that would be 10. Okay. Probably fit one more in on the sheet. Right, number 10. The slope is equal to 2, but that's also equal to y2 minus y1. No, y1 was r. Oh, interesting. Over x2, which is also r, minus x1 is 12. Okay, whatever. All right, so I think we're going to want to write that as 2 over 1, so we can do some cross multiplication. Interesting. All right, so 2 over 1 equals 6 minus r over r minus 12. That would have made a good quiz question, right? If I'd made one of these like an equation that had no solution, that would have been a good one. All right. Anyway, I'm thinking 2 over 1. Oh, no, I need to cross multiply. So 1 times 6 minus r, well, that won't change 6 minus r, and that's going to be equal to 2 times r minus 12. So 6 minus r equals 2 times r minus 2 times 12. Okay. I might start by adding 24 to both sides. Okay, but I've still got this r over here, so I'm going to need to add 1 r to both sides. And so I'll have 30 equaling 2r plus this other r is ending up being 3r. And I'm going to divide both sides by 3 and see that, oh, r needs to equal 10. All right, 2 more. Oh, we're over an hour. Oh, boy. So it's been a bit of a grind. So, all right, 2 more problems. We can do it. And I just recycled the problem set. That's not it. Oh, no. Here it is. All right, number 12. Rn 9, 7 and 5, slope is 6. Slope equals 6, but because of the way these problems have been going, I'm going to set it up to be a proportion. And that's going to be rise over run, y2 minus y1 divided by x2 minus x1. Okay, and then we're going to cross multiply. So I get 1 times, I guess I'll simplify first. 6 over 1 equals negative 4 over 7 minus r. Okay. So now I get negative 4 when I multiply these two, and 6 times 7 minus r. And that's negative 4 equals 6 times 7 is 42 minus 6r. Okay. Now I'm going to subtract 42 from both sides. Negative 4 minus 42 more is going to be negative 46. I feel like I'm making an error here. Equals negative 6r, because, yeah, 4 plus 6 is 10, and the digits of a number have to add to a multiple of 3 for it to be divisible by 3, and I'm looking for it to be divisible by 6. All the rest of these had whole number r values. I feel like I've definitely made an error. Let's see. Well, if I've made an error, I can't spot it. Maybe I've just been doing too much algebra today, but I'm just really not seeing any error here. And like I've been saying, but you know, improper fraction is not a automatically wrong answer. So maybe that's a good moral to, you know, if you've watched all hour and 6 minutes of this, or you've worked all the problems on the review, just be reminded, not all of the answers are always going to be nice integers, right? So I'm going to divide both sides by negative 6, and I'm going to get r is 46 over 6. These are both even numbers, so I can go a little farther and simplify, divide both in half. 23 over 3. Who knows? Okay, and it's a number. It's a rational number. Works for us. Okay, that's going to be all for this video. Thanks for watching. I really hope this helped.